Welcome back, everyone. Here we have finding the least common multiple and greatest common factor using the ladder or cake method for two numbers. We'll have a separate video for three or more numbers, but right now it is only two. So let's get into it. It is very similar to finding the prime factorization of a number. So if I were looking for the prime factorization of 18, right, and the prime factorization is a number written as the product of all of its prime factors, and we can find those definitions elsewhere in my materials. But we would use this upside down bracket and the list of prime numbers, which I like to list them up to 20. So there's 8 of them, right? And we can go to 13, 17, 19. So that's them, 2, 3, 5, 7, 11, 13, 17, 19. So I systematically ask myself, does the least prime number go into my next layer of my cake or my ladder? So in this case, yes, 2 does go into 18, and that renders 9. But then as I ask myself the same question for the next layer of my ladder or cake, does 2 go into 9? No, it doesn't. 3 does, and so on until I reach a prime number and I stop. My prime factorization is then all of those factors down the side written like so. So that's prime factorization. But when we're looking for least common multiple or greatest common factor, we would be looking for two different numbers, right? So I would be looking for, let's say as an example, 9 and 6. I could look for their least common multiple or their greatest common factor. The coolest thing about this is that I can use this method for both of them. So I would proceed the same way, but I'm going to check to see if it works for both numbers. So does 2 go into both of these numbers? 2 goes into 6, but it doesn't go into 9, so I can't use it. Does 3 go into both of these numbers? Yes, it does. So I can say 3 goes into 9 3 times, and 3 goes into 6 2 times. And just like in the prime factorization, I've reached 2 prime numbers, so I'm going to stop. Now, this is where it gets interesting. For the least common multiple, I would take all of my factors, 3, 3, and 2, and multiply them. And as we saw before, that's going to get me 18, and that is my least common multiple. But if I'm looking for the greatest common factor, the largest number that is a factor of both of these that they have in common, I'm only going to look right here. And I'm going to take the product of the factors down the left-hand side. Since there's only one factor, that is in fact 3, and that is my GCF, my greatest common factor. And this will work for any two numbers. We just may need to get creative. So let's try another example here. If we look at 8 and 20. Okay, now that's two different numbers, 8 and 20. We draw our bracket, and we ask ourselves the same question. Does 2 go into 8? Yes, it does. Does 2 go into 20? Yes, it does. So we may use it. That renders 4 and 5. Now here's the thing. Even though 4 is a composite number, right? 2 has a factor. Since 2 doesn't go into 5 and 4 doesn't go into 5, we have to stop. So just because this is a composite number, I can't get a number other than 1 into both of them. Their largest common factor is 1. So I'm done with this, and I once again have my answer. Here's your greatest common factor, 2. And 4 times 5 times 2, or 40, right? 2 times 4 times 5 is 40, which is your least common multiple. So this method works, and it's not always one step that it works. So let's try one more here. See if we can get a few more steps and show you that real cake setup, right? 12 and 30. So first step, yes, 2 does go into both numbers, 6, 15. Now in this case, we have to go again, neither go into the other, but they both have other factors. So 2 goes into 6, but not 15. 3, however, goes into both. So 3 goes into 6 twice, 3 goes into 15 5 times. Both are prime, I stop. So my greatest common factor in this instance is actually 2 times 3, which is 6, and that's my greatest common factor. And then my least common multiple is going to be 2 times 3 times 2 times 5, which, as you can see, 2 times 3 is 6, times 2 is 12, times 5 is going to be 60. So this works regardless of how many steps we have to go. I want to talk about a few specific situations. So one of them is the double prime, or occurring 2 prime numbers. So let's say I'm asked to find the least common multiple or greatest common factor of 3 and 5, both of which appear on this list. This would be true of any prime numbers. Since I don't have any factors that I can put into them other than 1, that is their greatest common factor. It is in fact 1. The least common multiple is going to be the first time that they cross over on their multiples, so that's going to be 3 groups of 5 or 5 groups of 3. So in that instance, 3 times 5 or 5 times 3 is 15, and that's your least common multiple. And that's going to work anytime you have 2 primes. Or you have a prime number. Let's say, as an example, that prime number is 3. And then we take a composite number of 10, right? So 10 has factor of 2, it has a factor of 5, but none of those numbers go into, oh, I'm trying to do division here, none of those factors go into 3. So in this case, I would also multiply them, right? So that's 30 as my least common multiple, and my GCF is again 1, because I can't get any factors into 3 other than 1. So there's no work that's going around on the outside, so I'm going to multiply them. And if you forget that, you simply try the work. You'll be reminded very quickly that nothing works out. The last one I want to show is the factor-multiple relationship. This one's pretty cool, and it's going to be helpful for both. So if we take the numbers 4 and 12, looking at them, I could do the work, right? I could draw the bracket, but I want to take a pause. If you notice that 4 is a factor of 12 and 12 is a multiple of 4, your work's already done, because 12 is going to become your least common multiple and 4 is your greatest common factor. And here's why. Since if I do the work, I'm going to ask myself what goes into it. 2, here I get 2, here I get 6. I could do this again, and anytime you get the 1, you know you've done something weird, and this will render your answers. So my greatest common factor, in this case, 2 times 2 is 4. 2 times 2 is 4, times 1 is still 4, times 3 is 12. So this works out to be your least common multiple and your greatest common factor. So since neither is prime, you could do the math, but you realize that 4 is a factor of 12, 12 is a multiple of 4. They have that relationship. They're going to help each other out. I hope you've enjoyed these videos. Please check back. We'll be doing much more of this.